Mrs. McHugh again. Today we're going to go over multi-step equations with variables on both sides of the equation. So before we did multi-step equations, remember that means using the distributive property, probably having to combine some like terms on each side. So we did those, but we only had the variable on one side. So now we're going to have variables on both sides. Okay, so here we go. Our first problem is going to be 5n plus 34 equals -2 times 1 minus 7n. Okay, so step one when we're solving an equation that has several steps to it in variables on both sides is going to be to look for the distributive property. My distributive property is a parentheses with that number on the outside, meaning I'm multiplying -2 times both of the terms that are inside. So our very first step here is to distribute. And I only see parentheses on one side of the equal sign, so I'm only going to be distributing over there. So I'm going to draw my lane for my equal sign. Remember, he stays in his own lane the whole time. I'm going to go ahead and multiply -2 times 1. -2 times +1 is -2. And then -2 times -7n. So -2 times -7 is +14, and that n stays right there on the back. I'm going to bring down the rest of the problem, and I have now done step one, which is to distribute. Step two is I'm going to look for any like terms. Do I have any like terms on this problem? Well, like terms means on each side of the equal sign. So when I write like terms, it means, do I have any like terms on the right side? Well, I have a constant, and I have a term that has a variable with it. These are not like terms. On the left side, I have a term with a variable, and I have a constant, meaning a number with no variable. So I don't have anything that's alike over there. So it looks like I'm not going to have to really work with this time. So there are no like terms. Okay, so the third step is going to be to look for the term that has the smallest coefficient. So I'm going to be adding or subtracting based on whatever the inverse is. The term with the smallest coefficient. What's a coefficient? It's the number in front of the variable. So I'm going to look at the terms that have a variable. I have a 5n, and I have a 14n. Which one is smaller? Well, 5n is smaller than 14n. So I'm going to do the inverse of this on both sides. Now, the reason why I work with the smallest coefficient is if I'm always adding or subtracting the smallest coefficient, it means I'm more likely to end up with a positive number I'm dividing by at the end. And then I don't have to worry about messing up a negative. Okay, so that's why I do that. So 5n is smaller than 14n. It's positive, so I'm doing the opposite, which is -5n on both sides. I draw my big equal sign, and now I'm going to work from left to right. 5n minus 5n is 0. So this has been eliminated from the left side. I bring down my +34 because it's the only term. I no longer need that plus sign. I bring down my equal sign. I bring down my -2, and I have 14n and -5n, which makes +9n. So I'm going to write plus 9n. Okay, now I have the variable on one side. It doesn't matter which side it's on. The two sides are equal, so it doesn't matter. So remember, I want to get that variable by itself. I have 9n over here with a -2. My goal is on this side now to only have one n all by itself. So it looks like I'm going to first need to make sure I have this term alone. So let's go ahead and eliminate this -2 from both sides. So step 4 is going to be to move the constant. Or instead of move, you can think of it as eliminating it from that side. So my constant is -2. So I'm going to go ahead and add it because that would be the inverse. And I'm going to again work from left to right. So 34 plus 2 is 36. Bring down my equal sign. -2 and +2 make 0. I've now eliminated this constant, and now I only have this one term on that side. However, I still have 9n. Remember, I want one n all by itself. So the last thing I'm going to do is the inverse of that coefficient. Okay, this is 9 times n. So I'm going to either multiply or divide. So in this case, I'm going to be dividing by my coefficient. So I'm going to divide both sides by 9. And then again, work left to right. 36 divided by 9 is 4. Bring down my equal sign. 9 divided by 9 is 1n. Yay! Now, before we move on, let's just talk for a moment about what this means. What does this mean that 4 is equal to n? Well, what that means is this is the only value of n that I can replace in the original equation where the left side and the right side would equal each other. And I'm looking for my eraser. Here it is. So I'm going to go all the way back here. And this is the only problem I'm going to do this on. My solution was that n is equal to 4. So that means that in the original problem, if I were to replace n with 4, the left side and the right side should equal each other. So if I evaluate this side using the order of operations, 5 times 4 is 20. 20 plus 34 is 54. So the value of the left side is 54. So this should also end up being 54. So let's take a look at that. I'm going to start with my parentheses. -7 times 4 is -28. So 1 minus 28 is -27. -2 times -27, sure enough, is +54. So the value of the left side is 54, the value of the right side is 54. And in this equation, n equals 4, that's the only number that's going to work. There is no other number that I could replace in for n where the left side and the right side would have the same value. So this problem has only one solution, and that is that n is equal to 4. So it's really important to remember what it means when we get to that answer. Okay, so let's go ahead and do another problem. All right, so our second problem today is going to have some like terms that we have to deal with. So problem number 2, we have 2 times the quantity 4x minus 3 minus 8, and that expression is equal to 4 plus 2x. All right, so here we go. Thinking about my steps from the last problem, which if you wrote them down on your notes, you have them to look back at. Step 1 is to distribute. So I'm going to look on each side, and I'm just going to abbreviate over here to remind myself what my steps are. Step 1 is to distribute. So it looks like there is a distributive property on the left side. I'm going to go ahead and multiply that out. So 2 times 4x and 2 times -3. So that makes 8x minus 6. I'm going to bring down the -8, bring down my equal sign, and there is no distributive property on the right side, so I don't have to worry about it. All right, step 2 is I'm looking for any like terms. So do I have like terms? And I don't know if that cut off over there a little bit. No, you can see it, I think. But do I have any like terms on each side? Well, on this side I have 3 terms. If there's 3 terms, most likely 2 of them are going to be the same. I'm going to have to combine something. So I have an 8x, then I have a -6 and a -8. These are both constants. Neither one has a variable. Those are like terms. I'm going to go ahead and combine those together. So -6 and -8 make -14. So I'm going to bring down my 8x. These two combine together to make -14. Bring down my equal sign. This is a constant. This has a variable. I've got no like terms on the right side. Do you remember what my third step was? Distribute like terms. Once I'm down to just a variable and a constant on each side, this is when I look for the smallest coefficient. Okay, and I'm going to do the opposite of that on both sides. So step 3, add or subtract the smallest coefficient. So I have an 8x on the left, I have a positive 2x on the right, and positive 2 is smaller than positive 8. So I'm going to go ahead and subtract that from each side because that would be the opposite or the inverse. All right, I'm going to draw my big equal sign and I'm going to work left to right. 8x minus 2x is 6x. I'm going to bring down that -14, bring down that equal sign, bring down that 4, and I have eliminated this variable on both sides, or on that side, so I don't need to bring it down. All right, now I'm on step 4. Step 4 is now I'm going to move that constant. Okay, when I say move the constant, I mean the one that's on the side of the variable. I'm isolating this variable, getting 1x by itself. So I'm going to start by eliminating this -14. So step 4, I'm going to, instead of writing move and eliminate, I'm just going to write add or subtract the constant because it's shorter. Okay, so the inverse of -14 is positive 14. And I'm going to bring down my 6x, bring down my equal sign. This guy is 18. He made 0. And now I'm on that very last step, step 5. And now this is where I have to look at my coefficient, and I'm going to divide by my coefficient. So I'm going to divide both sides by 6. 6 divided by 6 is 1. Yay, I have 1x by itself on the left side. 18 divided by 6 is 3. Okay, and what does this mean? This means there is only one solution to this problem. If I were to replace x with 3 on the left and right side, it means that the value of the left side and the value of the right side would equal each other. And there's only one solution for which that happens, and it's x equals 3. So this has one solution only. Okay, why do I keep telling you that? Is it possible that there would ever not be one solution? Because up to this point, everything you've solved has probably had one solution, right? Well, there's other possibilities. And as we get older, we start learning all those different possibilities. So let's take a look at what happens when there's not one solution. All right, next problem. This one's a little bit shorter. Problem number 3 is p minus 4 equals -9 plus 5 plus p. And notice that we can use any letter that we want. A variable just stands for an unknown value. Okay, doesn't matter if we use an A, B, C, D, E, F, G, or a B. So I'm going to start off the way I always do, which is drawing my lane for my equal sign. Step 1 is distributive property. I don't see any parentheses in this problem. I don't have to do distributive property. Yay, less work for me. Second, I'm supposed to look for like terms. This only has 2 guys over here, and one has a variable and one is a constant. They're not alike. Over here I have, a constant and a variable. I'm going to go ahead and combine those constants. So -9 plus 5 is -4. I'm going to bring down that positive p, bring down my equal sign. And when I'm combining a like term on one side or doing a distributive property on one side, that's the only time I don't really work left to right. Whenever I do something on both sides, I work left to right. Otherwise, I usually kind of go with the side that the work is on first. Okay, so now I'm at the step where I'm supposed to look for the smallest coefficient. So I have a p on this side. I also have a p on the right side. But they're both equal. There's not one that's smaller, so does it matter which one I do? Yeah. I'm just gonna go ahead and take this one. I'm gonna subtract him from both sides. So now p minus p, I've eliminated the variable from that side. I'm gonna bring down my -4. And my mind starts working right now. The little hamster that's in my head is going, and then he's going, huh? Wait a minute. This looks weird because it's gonna eliminate over there too. What do I do? Because the next step is supposed to be that I'm supposed to add the constant to both sides, but I'm supposed to add the constant that's on the same side as the variable, and there's no variable. What do I do? Okay, so when this happens, when my variable eliminates on both sides, I don't have to go any further. That's the good news. These are a little bit shorter. I'm going to look at what I have left. It says -4 equals -4. Is that true? Is -4 equal to -4? It is true. This is a true statement. Because this is a true statement, I'm going to write down true statement. Although that's not the final answer. That's really more just for you to see. If, when your variables eliminate, you are left with a true statement, it means that there are infinitely many solutions to this problem. Take the time, please, to spell that word infinitely right, and let's talk about what that means. Okay, so we talked about on the first problem when there's one solution, it means that that number can be replaced in for the variable and the left and the right side are going to equal each other. Well, when there's infinitely many solutions, think about what infinitely many means. Tons and tons and tons and tons, okay, to infinity. There's so many, we can't even count them all. So there's so many solutions for this, you can't even count all of them. Any number that you choose to replace in for the variable is going to work in this problem. Pick a number, any number. Well, since I can't hear you, I'm going to have to pick my own number. Let's pick 7. If I were to take the original problem and I were to replace the p with a 7, what is 7 minus 4? 3, right? What is -9 plus 5 plus 7? 3. The left and the right side equal each other. Well, what if I didn't use 7? What if you said, well, I don't want to use 7, I want to use 5? Well, 5 minus 4 is 1. -9 plus 5 plus 5 is 1. So again, the two sides equal each other. So it doesn't matter what number I choose, every number is going to work. And do you know where I really could see that is right here. Right there, I noticed that the left side says p minus 4. This side says -4 plus p. These are exactly the same. When those sides are exactly the same, you'll also sometimes see this called an identity. Think about your identity. My identity is when I look in the mirror, I see myself, right? So this guy looks across the equal sign and sees himself. That's called an identity. So when you have an equation that's an identity where the two sides are exactly the same, you're always going to end up with infinitely many solutions. Okay? All right, so let's see what happens. What happens if there's not infinitely many solutions? And if there's not one solution? What's the only possibility that's left? 2 solutions, 3 solutions, I don't know, let's see. So let's do one last problem together. The last problem we're gonna do, problem number 4, is 24a minus 22 equals negative 4 times 1 minus 6a. All right, let's take a look at this guy. Here we go. Step 1, hopefully you're remembering your steps by now. Step 1 is to distribute. So negative 4 times 1 is negative 4. Negative 4 times negative 6 is positive 24, and that a stays on there. I'm going to bring everything else down. At this point, my antennas start tingling. No. You know why? Because I'm noticing again, when I get to the step of looking for my smallest coefficient, they're both the same. Now I skipped combining like terms because there are not like terms on either side. We have a constant and a variable. Here we have a constant, we have a term with a variable. So I'm immediately going to need to add or subtract the smallest coefficient, but they're both the same. Well, last time when they were both the same, it was infinitely many solutions. Is that going to be the same thing that happens now? Well, let's double check. So I'm going to go ahead and just take this one, and I'm going to do the inverse on both sides. So 24a minus 24a, the variable has eliminated. That makes 0. So the only thing I'm left with over here is negative 22. I'm going to bring down my equal sign, bring down the negative 4. 24a minus 24a, it's eliminated over there too. But last time I had the same number on both sides. This time I have different numbers on each side. Is that a true statement? Is negative 22 equal to negative 4? No, negative 22 is less than negative 4. So I guess that means this doesn't have infinitely many solutions. It means that it has no solution. So I'm going to write here, again, just for your visual, this is not a true statement. So when you are left with a constant equaling a constant and they're not the same, and it's not a true statement, there is no solution. What does that mean, that there's no solution? You know, no solution means that there is not any number that you could replace for a where the left and the right side are going to equal each other. And you know where I saw that? Right here. This is not an identity. The 24a and the 24a are the same, but these numbers are different. If I take 24 and multiply it by a number, and on this side I do the same thing, 24 times a number, but on this side I subtract 22, and on this side I add negative 4, am I going to get the same answer? There's no way that I could get the same answer. If this number and this number are exactly the same, but I'm subtracting different amounts, there's no way they're going to be the same. So when I saw that my coefficients were the same, but my constants were not, that was my heads up that this was going to be no solution. So this is an answer that has no solution. So hopefully you wrote all of these down. If you didn't, I would really advise you to do that. I know that you have this video that you can go back to, but it's 24 minutes long right now, almost 25 minutes long. So it's kind of big to scroll through, okay? So hopefully this helped you today. You are gonna have some practice to do. And if you need any help, you know where we are, okay? Bye.